Dear viewers, welcome to our lesson today. This is a continuation of the series of lessons that we have been having on remote learning. I am your teacher, Mr. Steve Getao. I'll be taking you through mathematics. We shall have a lesson focusing on revision on mathematics for Kcse Mathematics Paper 1. In particular, the reason why we are having this lesson is to look at some of the common mistakes students make in Kcse and how to avoid them. We shall do this through a series of questions which I'll guide you through in a recorded lesson for 30 minutes. And the remaining 10 minutes, we shall have an interactive session in the live section whereby I'll get your feedback out of the activities that I would like you to work out in the lesson. Welcome and let's get moving. In our question number 1, we shall look at SATs, a question on SATs. The question is, viewers, let us get our notebooks. We write as we discuss this question. The question says, question 1, simplify root 5 all over root 5 minus 2, leaving your answer in the form a plus b root c, where a, b, and c are rational numbers. Viewers, the reason why I picked on this question is so that we may have the skill of following the instructions. Keenly, let us see that we are instructed to leave our answer in the form a plus b root c, whereby the a, b, and c are rational numbers. Let's get solving the question. In the solution to this question, we take root 5 all over root 5 minus 2, we multiply by the conjugate of root 5 minus 2, which is root 5 plus 2, both on the denominator and also on the numerator. And the first step is we open the brackets. Root 5 by root 5 gives us, let's use this space, it gives us root 25 minus root 5 by 2, that is positive 2, we get 2 root 5. On the denominator, root 5 by root 5 will give us root 25. Root 5 by 2, we get positive 2 root 5. That is negative 2 by root 5 is negative 2 root 5. And finally, negative 2 by positive 2 is a negative 4. Now, we simplify this further because we know we can have root 5 being expressed as 5, and then this remains as it is, 2 root 5 all over. This simplifies out as a 5, and we find that this 2 cancels out to be 0. Positive 2 root 5 minus 2 root 5 is a 0, and we subtract 4, and that gives us 5 plus 2 root 5 all over 1. Viewers, if we were to pause there and see the marking, supposing a student leaves his working in an answer at this level, what will happen? The examiners will give him an M1 for correct conjugate multiplied on the numerator and denominator. We shall have, after the learner has simplified this part and arrived at this level, you get an M1. But when the learner leaves the answer with this unsimplified part, the division which is possible, but the learner has left it with a possible division, he gets an A0. So what should it be? The learner is required to simplify this and work it out as 5 plus 2 root 5. Simply because take a value like 100. If you divide by 1, you get a result which is 100. So here there is some working which is required to be done. The learner should not leave the answer with some possible working. So at that point, then this learner gets an A1 and is able to score 3 out of 3. Let's move on to question number 2, also on simplifying SATs. In question number 2, we are going to have simplify 4 all over root 5 plus root 2 subtract 3 all over root 5 minus root 2. In this kind of question, we see that we have different numbers on the denominator. What do? Supposing we had a question with the denominators being 8 and 7, the LCM to that would be 56. So when we have this and we need an LCM, the product of the two serves as our LCM. This, or what we are showing here, is method 1. I know there is an approach 2, but let us look at method 1 for now. What do? We have the LCM being the product of the two, that is root 5 plus root 2, root 5 minus root 2. So we divide all this by the first part, we get the partner here. So that will be 4 into brackets root 5 minus root 2. Subtract, when you divide all this, you divide all this by this, we get the partner here. So that is negative 3 into root 5 plus root 2. So at this point, I would like us to open the brackets. 4 by root 5 is 4 root 5. 4 by negative root 2 is negative 4 root 2. Subtract, 3 by this is 3 root 5. Negative 3 by positive, you get a negative 3 root 2 all over. Look at the denominator. Root 5 by root 5 is root 25. Root 25. Root 5 by negative root 2 is negative root 10. This by this is positive root 10. Root 2 by negative root 2 is negative root 4. So with that, we once more see commonality here. This cancels out with that one. And then we work out the like terms in the numerator. This is a like term to this, and this is a like term to that. So putting the two together, what do we get? 4 minus 3 gives us a 1 root 5, which sometimes we don't necessarily write the 1, but we shall write 1 for emphasis. Negative 4 minus 3 is negative 7 root 2 all over. Root 25 is a 5 minus root 4 is a 2, and that gives us root 5 minus 7 root 2 all over 3. And that serves as our final answer for this question. So we do the marking and we see the use of the respective LCM, which is serving as a conjugate, and that gives you M1. When the student is able to simplify this expression and arrive at this final step of the working M1, and the answer here A1, which is accurate, and the student earns 3 out of 3. I would like us to get an activity which we shall report during our live session, and that will be in the 10 minutes of this 40 minutes lesson. The activity 1, which is drawn from SATs, I would like you to note it down, work it out, and then you report on what you get. You are given, you are requested to simplify root 14 all over root 7 minus root 2, subtract root 14 all over root 7 minus that is plus root 2. So we work out this, note it down in your notebook. We shall work it out during the live session, and then we shall have members who are live in this lesson report, or still you'll be able to put it as a comment. Let's move on to a second part of this discussion, and this will be on trigonometry. Trigonometry, which we covered in Form 2. The question will be our question number 3. Question number 3. It says that given sine 2x degrees being equal to cosine of 3x minus 10 degrees, find what is tan x correct to 4 significant figures. And this is a question worth 3 marks. So in this particular question, we are required to recall Form 2 work, which is the rule of angles that add up to 90. How are their respective sine and cosine? So the rule says that if angle A and angle B add up to 90 degrees, then the sine of angle A will be equal to the cosine of angle B. That is the rule where angles are supplementary. The angles add up to 90. In this case, let's see, how do we now tackle it? We shall have 2x as the angle, added to the other angle, 3x minus 10, and that gives us 90 degrees. A plus B equals 90 if sine and cosine are equal. Put like terms together, we get 5x is equal to, we shift this on the other side, we get 100. And therefore, divide by 5 both sides, divide by 5, we get that x is equal to 20 degrees. However, the question asked us to evaluate tangent of x. So what is tan 20? Viewers, let us get it interactive. From your calculator, punch tangent of 20. Tangent of 20. From my side, I get that this is equal to 0.36 3970. 0.36 39 with a 70 there. So these are how many significant figures? 1, 2, 3, 4. We check on the fifth, which is a 7, and that gives us, we add 1 to 39, and we get 0.3640. Viewers, at this point, I want us to do a supposition. Suppose that a learner leaves his answer in the form as 0.364 and ignored that 0. You realize that this is the significant figures. We are talking about 3 significant figures. Yet the question talked about 4. So the learner is required to obey the instructions and be careful about the final answer. The accuracy is to 4 significant figures. So we get an A1, correct knowledge of angles that add up to 90, M1, getting 20, M1, and the learner is able to get 3 out of 3 in such kind of a question. So viewers, I would like to get you to an activity number 2, activity 2, which will be drawn from trigonometry. We are given that the sine x plus 60 degrees is equal to cosine 2x degrees. The question is, find the tangent of x plus 60 degrees to 4 decimal places. and that should earn you 3 marks. So put down this activity 2. We shall have a reporting section in or during the live section. We are going to move to question number 4, which will be drawn from an area in logarithms. That is further logarithms as done in Form 3. Question number 4. We look at a common area in further logarithms as dealt in Form 3, whereby we look at the rules of logarithms. If we can review very quickly, the various rules of logarithms says that where we have numbers multiplying, if you have a multiplied by b, the logarithm to that will be the log of a added to the log of b. In the second law, we have a divided by b. The logarithm to this will be the log of a subtract the log of b. And we also have a law that says if a is raised to the power of n, and that becomes a product b, and you take logarithms on both sides, it will imply that the power becomes a multiplier, and log of a will be equal to the log of b. So viewers, these 3 laws of logarithms will be very crucial in our answering of question number 4. Let's get started. At this level, we see rule number 3, whereby the multiplier becomes a power here. So we shall have log of 15 squared subtract log of x being equal to log 5 plus log x minus 4. So we have dealt with the third law. Let's come to the law involving subtraction, that is number 2, and also law number 1 involving addition. What do we get? We convert to 15 squared to 225, and that comes to be the logarithm of 225 divided by x. That is subtraction of logarithms, we divide the numbers, and that gives you the logarithm of, when we are adding logs, we multiply the numbers, and that will be 5 into x minus 4, and we close the bracket. At this level, the third step is to drop the logarithms. So we shall have 225 all over x, and that is equal to 5. You can open the brackets and get x minus 20. So that is a very crucial step, and we are reading to a quadratic equation. We need to cross multiply so that we have a linear equation. So we cross multiply that, we cross multiply x with that. 1 comes here, x comes here, and we get, let me use this space here. So that gives you 225 is equal to 225 times 1 is 225. X by this is 5x squared minus the x multiplied by negative 20 is negative 20x. So let me put that one down a little bit at a lower level. So we shall have 225 is equal to 5x squared minus 20x. We write it in the proper way, starting with the x squared, so minus 20x. We subtract 225 from both sides, we get negative 225, and it gives us 0. We can simplify this equation by dividing throughout by 5. And what does it give us? It gives us x squared minus 4x minus, viewers, from your calculator, 225 divided by 5 gives us 45 is equal to 0. So we look for two numbers whose product 1 by 45, that is product is negative 45, whose sum is negative 4. Which are those possible numbers? Which are those possible numbers? We get negative 9 and positive 5. You multiply the 2, you get this one. You add the 2, you get negative 4. So we move and we substitute these two here. What do we get? That x squared minus, we start with 9x plus 5x minus 45 is equal to 0. So from these two, what is common? X is common. We factor it out and we get x minus 9. And then from these two, what is common? 5 is common. And we factor it out and get x minus 9 is equal to 0. So at that point, we can get the factors as x minus, plus 5 and x minus 9 is equal to 0. So at this point, we take either that x plus 5 is equal to x plus 5 is equal to 0. That means x is equal to negative 5, or we have that the other bit, x minus 9 is equal to 0, so x is equal to 9. Viewers, it is important to be cross-check how accurate that the answers will be when substituted into the equation. So we take that when x is negative 5, when you place it here, on the calculator, logarithm of negative 5 is undefined, so it gives you math error. That means we have to disqualify. We have to disqualify x is equal to negative 5. We disqualify it because it is not working as per the equation. Even when you place it here, negative 5 minus 4 gives you negative 9. Logarithm of negative 9 is not defined. But when we take x equal to 9, log of 9 is defined. And when we take x here, 9 minus 4 is a 5. Log of 5 is defined. So we can conclude and say that it's only when x is equal to 9 that we are able to have that question solved like that. So in marking, let's look at how do we award the marks. When the student is able to form a quadratic equation either at this level or at this point, this is the most appropriate point, M1. Solving out and getting the factors at this level, we get M1, and when the student is able to have the correct accurate answer alone, and this one disqualified, then we award 3 out of 3. What are we learning here? If the student did not disqualify this answer, left it on the paper, the A1 is lost, because he is saying that, or she is saying that both answers are accurate, whereas this is not an accurate result. So I would like us to look at activity 3, which is going to be drawn from the work in logarithms. Let's look at a question for activity 3. Activity 3. In activity 3, we are required to solve a logarithmic equation which says solve for x in logarithm of 7x minus 3 plus 2 log of 5 being equal to 2 plus log x minus 3. So viewers, x plus 3. I beg your pardon. So we have this equation, which will be our question for activity number 3. I'll give you some 10 minutes at the end of this recorded lesson, whereby you report during the live section on this one. Let's look at the final part, which is a question on solving linear and quadratic equations. How do we go about solving linear and quadratic equations? That will be our question number 5. Question 5. We are required to solve for x and y, given that x squared minus xy is equal to 4, 3x minus y is equal to 9. So how do we go about this one? The simple rule in geography which says the smaller liver drains into the bigger liver. So this linear equation will be substituted into the quadratic equation. How do we go about that? By writing this equation so that we have one unknown being the subject of the equation. That means 3x minus 9 is equal to y. We push the y on this side and we bring 9 on this other side. In other words, we shall have that y is equal to 3x minus 9. That way, this expression now, we are going to substitute it into where we have y in equation 1. That will lead us to x squared minus x. Instead of y, we put in this part 3x minus 9, and that will give us a 4. So we open the brackets at this point, and we shall get x squared minus 3x squared negative x multiplied by negative 9 is plus 9x, and that should be equal to 4. Putting like terms together, 1x minus 3x gives you negative 2x squared, negative 2x squared. Then we have plus 9x. We bring this 4 onto this side, minus 4 to get us a 0. Now that quadratic equation, we can make it have the multiplier of x squared being positive by multiplying it out by negative 1. And that will give us, we can use this space, 2x squared, negative 1 by negative 2 is positive 2. Negative 1 here is negative 9x. Negative 1 onto negative 4 is positive 4, and that gives us 0. At this point, we look for two numbers whose product, this and this, the product is 8. Two numbers whose sum is negative 9. And those two numbers, let us work them out. Which are they? We get a negative 1 and a negative 8. Check. Negative 1 by negative 8 gives a product of 8. Negative 1 by negative 8 gives us a sum of negative 9. So bring them in the middle term. And what do we get? 2x squared minus, we can start with negative 1x. Then we go to negative 8x. Add 4, get equal to 0. So factor out what is common in 2x squared in 1x, we get an x. And you're left with the 2x minus 1. What is common in negative 8x and in 4? So we have, we factor out a negative 4, so that we are left with the 2x. We are able to match 2x and this 2x by having the negative 4 out. Now, what do we do? How can we get a negative 4 out or factored out from positive 4 if we have a negative 1? Confirm. Negative 4 by negative 1 is positive 4. So we are right at that one. So put the factors together, x minus 4 into, and or rather with 2x minus 1 is equal to 0. So how is this one? We can split this into 2 and say x minus 4 is equal to 0, and therefore x is equal to 4. When x is equal to 4, we come to this value expression for y. We get that y was supposed to give us 3 into, the value of x is 4, and then subtract 9. This is 12 minus 9, and therefore y is equal to 12 minus 9 is a 3. We are supposed to pair that. We pair that y with x as 4, and we put that together. We pair them together like that. We come to this other part. 2x minus 1 is equal to 0. Therefore, 2x is equal to 1, and therefore, finally here we get that x is equal to a half. We need to work out the value for y, and we had been given that y is equal to 3. The value of x is a half minus 9. So how does this one come about? This is y is equal to 1.5 minus 9, and that y comes to be negative 7.5. We pair that with x is equal to, the value for x here was a half. So these two are paired. Now, let's come to the marking for this question. in the marking for this question, we need to have the substitution of the linear into the quadratic M1. When the student is able to get the quadratic equation and the correct factors at this level, we get the other M1. And the most interesting bit is the answer is awarded for A1 both. So we shall have to look at, did the student get the two sets correct? Were they paired? You get A1. At times the students write only one answer, leaving out the other one. Now that student will lose the A1. So it is important that we are able to pair the two answers so that we get the 3 out of 3 marks. So viewers, we have come to the end of our recorded part of the lesson, and I would like you to join me in the live section whereby you will be able to give feedback into the questions, the activities that we are posing. The final activity will be for this part, that will be activity number 4. Activity 4 will require us to solve for P and Q in the set of equations P squared plus 3Q squared is equal to 43. P plus 3Q is equal to 13. So viewers, this lesson has been recorded and it's available on my educational YouTube channel, whose handle is at Steve Getao, that is 660. Kindly search for this on YouTube, subscribe, and you'll get many more videos in mathematics and in chemistry. Let us see you in the live section.